Hi everyone, we're going to do some revision on simultaneous equations. Remember to pause the video at any time, and if you need anything repeating, you can obviously rewind. So, this is our first example. We've got two equations, first one and the second one, and we're going to solve them at the same time, solve them simultaneously. So at the end, what that's going to look like is I would like to know what x is, and I'd like to know what y is as well. Now, what we've been used to doing when we solve equations would be something like 3x minus 2 equals 13. Okay, and we'd be able to solve that by adding 2 to both sides and getting 15. 3x equals 15, x equals 5. Okay, and that's fairly straightforward. But to do with this one, we've actually got two things that we don't know, two variables, whereas we only had one here. So it's not going to be as straightforward as that. It would be useful, though, if I could kind of get this so that I was only looking at the x's or looking at the y's. So I'm going to try and eliminate one of those. So I'm either going to try and get rid of those x's, or I'm going to try and get rid of the y's, just so I get something a bit more straightforward that I could work out, like this. So in order to do that, I'm going to have to try and change this or adapt it so that I have the same number of x's or same number of y's. So I've got a bit of a choice. I can either make the x's the same. So what I'd need to do is I'd need to find a common multiple of 4 and 5. So that 20. So I could make both of these, say 20x, by multiplying this top equation by 5, because that would give me 20, and multiplying this bottom equation by 4. So I'm going to do that. What I could also do, though, is I could have made the y's the same. So I could make those both into 6y by multiplying this one by 3 and this one by 2. So I do have a choice, and I'm going to choose to do the x's because that was the first one I thought of. So I'm going to multiply this one by 5 and this one by 4. And I always write it down to one side then. So underneath, I'm going to multiply this whole top equation by 5. So that'd be 20x plus 10y. And take your time while you're doing this because we wouldn't want to make a silly mistake. 10 5s are 50. And I'm going to multiply the whole bottom one by 4, which gives me 20x. That's what I was expecting. That's what I wanted. Plus 12y equals 48. Okay, now the reason I've done this is so I can eliminate, get rid of one of these things, x or y. So what I can actually do is here and subtract one equation from the other. So this equation at the bottom, subtract this equation at the top, would leave me with 20x minus 20x would be 0. So I've eliminated the x's. But then I would have 12y take away 10y, which is 2y. And be careful here, because I'm starting with this equation and then subtracting this one, 20x take away 20x, 12 take away 10, 48 take away 50 is minus 2. So I now know that 2y equals minus 2, and that's nice because y would therefore be negative 1. Remember what I said at the start, I wanted to work out what x and what y is. So I've got y, so now I need to work out x. And the way to do that is I'm going to substitute in, because I now know that y is negative 1. So I'm going to come back to one of my equations, and I've got a choice again. But I'm going to use the fact that I know that y is negative 1. So in this top equation, it's 4x, and I know that 2y would be 2 lots of negative 1, because I've just worked out that that's negative 1. So that would be negative 2. So I've got 4x plus negative 2 has to equal 10. If I add 2 to both sides, I would get 12. So I now know that 4x is 12, and therefore x is 3. And I would put my answers together there. So I know that y was negative 1 and x was 3. It's a grade 5 example of a simultaneous equation. Not an easy one because of the negative. And particularly, I think the step that might throw a few people off is when we've subtracted this to make sure that we're doing it the right way around and getting that negative 2, rather than just looking at that and thinking, oh, 50 take away 48 is 2. So 2y is 2y and 1. So you've got to be careful with that one. Okay, we'll try one more, and then you could go away and you could try some yourselves. Okay, so what's the difference this time? I've got, well, I seem to have a negative sign here, and I didn't before. Actually, I've got as well, but there's 2y, and we've got 2y here. So unless I want to make the x's the same, because I really, really want to, I could just actually leave this one as it is, because I do have the same coefficient of y. So I don't actually need to multiply this one. Like the last one, I multiplied by 5 and 4. I don't actually need to do anything with this. I can eliminate straight away because I have the same number of y's. However, and you may know what's coming here, if I try and eliminate these, what we did last time was we subtracted. Now, I wouldn't write this down, because if I do 7x subtract 3x, that would be 4x. But then 2 subtract negative 2 doesn't give me 0. It doesn't get rid of the y's. That would give me 4y, in fact. So subtracting these equations would be no good. So what could I do to negative 2 and 2 so that they gave me a total of 0? Add them together instead. So if I add these two equations, 3x plus 7x is 10x. Negative 2 plus 2, so negative 2 plus 2 is 0, so it's eliminated. And 7 plus 13 is 20, so therefore x equals 2. Now we'll substitute that in. I'm going to use either equation is fine. I'm going to use the bottom one this time just because I used the top one last time. So 7x would be 7 lots of 2, that's 14. I always write it down like this. Plus 2y equals 13. And another way of thinking about it is like this. If I was to cover over the 2y and thought, right, what number would have to go underneath there so that 14 plus something is 13, I would then think, right, that's got to be negative 1. So underneath the ruler must be negative 1. So 2 somethings have to be negative 1. It must be negative 0.5. So x is 2 and y is negative 0.5. And we could present our answers together. X is 2, y equals negative 0.5. Hope that's helped a little bit. Two quite tricky examples there. Go on to Maths Genie and maybe try some, or on to Corbett Maths. And if you need any extra help, please ask your teacher. Thank you.